What do you guys remember about the chain rule?
Nothing.
Nothing?
I'll probably remember.
Hey, Parker, before you sit down, see that cup of coffee right there? Do you want to become my favorite student?
Sure.
Oh my god. Derivative of the outer.
All it takes is to bring me coffee. And you're automatically my favorite
Oh, I
student.
remember.
Derivative of the outer.
What perks does this give me now?
Well, you're my favorite.
Let's go. 5%.
All right. All right. So if I take the derivative of f of g of x, so now this is a composition of two functions, yes? Okay? And I take the derivative of that with respect to x. What is it? F prime of g of x times g. Oh, it is not f prime of x. It is f prime of g of x. Yeah, I need to sit in when she does the M&M's example now that I'm teaching.
Yeah, where she gave out like peanut M&Ms and it's like, because that it's like layered. No, but
Like an
peanut
ogre.
M&M though, because it's got like peanut, the chocolate. And the
And guys, if you think of
It's like a thing.
if y is equal to f of some function u, we might look at this as dy du times du dx. Hopefully that looks a little bit familiar. Okay, so the derivative of y with respect to u times the derivative of u with respect to x, those du's cancel and I get dy dx, yeah? And that might come into play when we start doing some integrating. But both of these are just different ways of writing our chain rule. So I was going to let you guys work a few examples and then we'll kind of come back to each other. And then I was going to give you guys a little bit more. You guys give it a shot, see how you do. So for example, sine of 3x. We would take the derivative of the sine of the 3x. Yeah, which would be cosine of 3x. But then that 3x is that inside function. So we'd have to take the derivative of 3x, which is 3. And I probably would write that as 3 cosine 3x. Is this ringing a few bells?
Yeah.
All right, go ahead and give this one a shot. It's like way harder?
A little bit.
What if I told you that that is 4x squared minus 2x plus 3 all to the 1/2 power? Does that help?
Yeah.
Is tangent square of x the same as tangent of x squared? Or is it tangent of tangent?
Did I do something wrong?
No, I definitely did something wrong.
What do we think so far of what we've done here? Okay. And then I would probably rewrite this with that square root on the bottom. Since it's to the negative 1/2, I would put that 4x squared minus 2x plus 3 on the bottom and underneath the square root sign. And then I would take the 1/2 and the 8x minus 2 and call that 4x minus 1. What do we think? Chain rule's fun? Not so much? So if I give you tan squared of x, guys, that's no different than saying the tangent of x, the quantity squared. So if I go to take that one, I'm going to start with dy dx. I'm going to say 2 times the tangent of x, that's just taking the derivative of that outside function, times, then we have to use the chain rule, multiply by the derivative of the inside function. What is the derivative of tangent x?
Secant squared.
Wow, these are getting worse. Why don't you guys try just for right now? I'll have you do A and C. You guys want to check how your answers compare to mine? Yeah, and I have it here. I just didn't. Yeah.
Is the 20x to the third as well? Yeah.
Yeah. What do we want to talk about? And we all agree on C? All right, why don't you guys give B a shot? Thoughts? What are we thinking? So this is a quotient rule, right? So the first part of the quotient rule, we keep the top keep the bottom the same, multiply by the derivative of the top. So this is if this is f of x over g of x, right? The quotient rule would be g of x times f prime of x minus f of x times g prime of x, right? All over g of x squared, yeah? Okay, so here's my g, here's my f prime. Here's my f. And so really where the chain rule comes into play is just taking the derivative of the denominator, right? So we're going to put it to the 1/3 power, to use that power rule, and then we have to multiply by a 2x again because of the derivative of the x squared, and then we just put the denominator squared in the bottom. Is everybody good? And for right now, I will accept this answer. When we get into, say, the next unit where I'm going to ask you guys stuff about concavity and slope and increasing and decreasing, that's going to change a little bit. For right now, though, I would accept this as your answer. Because to me, this is the derivative. Is everybody okay? Try this one. Thoughts? Are we doing on a scale of 1 to 5, 5 being I totally get this, 1 being I have no clue what's going on? Can you guys just give me a... Cool. don't you guys try A?
What? It's funny, like, if you like, I don't think they're horrible right now, but like, if you like touch fabric, it like goes like, sometimes like, depending on what I do, it's like, they'll be like more sticky out, like scratchy. Like, I'll touch my face and then it's just like, oh, like I'll scratch my face. That's lame. I don't like it. It's like the feeling like after like the AP writing test, you have to handwrite like handwriting like 3 different essays. Yeah, no, I don't do a lot of handwriting. Nor do I do a lot of writing.
Yeah, it's weird now that I know that they're there.
Yeah. Sometimes like sand them down, so it's like not like dead skin. Like the callus is still there, but it's like, but yeah, it doesn't have the sharp parts. Yeah. It's weird when your skin's like sharp.
Have you ever, like,
Yeah. Yeah.
How did I do, y'all? So maybe the first thing we did was 3 times sine squared of 7t, right?
Oh, okay, I see.
And then we would have to take the derivative of the sine of 7t, right? Which would be the cosine of 7t. Is everybody with me? Except for I still have another piece inside there, so I'd have to multiply by another 7 because of the derivative of just the 7t.
Well, shouldn't it be sine squared 17?
Yeah, that's what I wrote there.
Well, yeah, totally.
Yeah.
Yeah.
Is this okay?
Yeah, it is.
This one? This looks worse than it is. What's the derivative of e to a power?
It's that, but then you gotta like change.
It's just e to that power, yes? So this is going to be e to the x squared minus 5x, but then what do we need to do with that? We have to multiply by the derivative of that exponent, right? Which would be 2x minus 5. Yes? No?
Yeah.
If you guys need to, you could think of this as, if you want to think of it this way, and honestly, with where we're going next, once you know what that interior function is, right, I could look at this and say, I need to find the derivative with respect to x of e to the u power. And how do I do that? I multiply, well, I could find the derivative of e to the u is e to the u times u prime, yeah? That's what that chain rule really says. Well, the derivative of e to the u is e to the x squared minus 5. And if I have x squared minus 5 and take the derivative of that with respect to x, I'd get du dx. So you have some like different ways you can think it through, but really it's e to some power that stays the same times the derivative of that power. All right. What do you guys know about the derivative of the natural log function?
1 over.
1 over whatever, yeah? Except for it's not just 1 over u,
Times d.
it's 1 over u times du dx, yeah?
How do you do? Is it different for different bases of log?
It will be, and I don't know, do I have examples of that?
Well, I think.
Yeah, if you look at like where we're going with this, there's plenty there. But you can just use the change of base formula that we kind of talked about.
We
But
kind of talked about that. I'll have to go back and look.
yeah. All right. So guys, if I asked you what is the natural log, the derivative of the natural log of 2x? So in this case, we would do, well, just the derivative of natural log is 1 over that value, yes? So that would be 1 over 2x times 2. And for something that simple, guys, I think it's a reasonable expectation that you know that that is 1 over x. 1 over 2x times 2. Let me simplify that a little bit. Now, can I give you guys a piece of advice? You guys with me so far? That's what, just rewriting this? Now, how many of you want to do 1 over the square root of x plus 1 times, and then take the derivative of the square root of x plus 1? That feels like that's what we're supposed to do, right? So one of the things that can be really helpful, especially when we're dealing with logs and exponentials, is to go back and remember some of those properties of logarithms, okay? I'm allowed to bring, without changing anything, I'm allowed to bring that 1/2 down in front. You with me? And when I do that, I now have y equals 1/2 times the natural log of x plus 1. Which one do you think is easier to take the derivative of? The second one is way easier. So what does that make my derivative? 1 over 2 times the quantity x plus 1, because I can, and then technically I should take the derivative of x plus 1. What is the derivative of x plus 1? 1, so it doesn't matter. Now, if we did it this way, this other way, I would get 1/2 times x plus 1 to the negative 1/2 times 1. I get 1 over the square root of x plus 1 times 1 over 2 square root of x plus 1. And then when I multiply square root of x plus 1 times square root of x plus 1, I get 1 over 2 and then the x plus 1. I end up the same place. Just put primes on these. Okay? I end up in the exact same place. But one is a heck of a lot easier. So the reason last week or a little bit ago we went over all those different properties of logarithms, and the reason you had to learn them to begin with has nothing to do with everybody needs to know how to do a logarithm. The reason you learn those in pre-calc is that they can make calculus easier. Sometimes they make calculus harder. It just kind of depends. Is everybody okay? All right. Whew. This looks miserable, doesn't it? All right, so if you want, we could do 1 over all this, and then some quotient rule and some chain rule and amongst other things. But usually people don't want to, like, they look at this and kind of feel like that queasy feeling in their stomach. I look at this and I'm like, I don't want to do all the algebra associated with all the different rules. Is it safe to say that you guys don't either? Okay. Now, a few weeks ago we talked about these different log properties. And I'm just going to write it first and then let you guys look at it. And see if this looks kind of familiar compared to those properties of logarithms that we did. That anything being multiplied was like adding the two exponents, right? And anything being divided was like subtracting the exponent. And so I'm really just like, there's a plus sign and they each get their own natural log. I bring that exponent down. This one's subtraction because it's in the bottom. It's got a negative exponent. Are we comfortable with this? I haven't changed my function. I've just rewritten it in a way that's way easier to take the derivative. If I ask you to take the derivative of this function, is it not super, well, it's not super easy. It's definitely not super easy. But I think it's not as bad, right? What's the derivative of the, so if I go to take the derivative, now I have these separate terms. What's the derivative of the natural log of x? 1 over x plus, what's the next one going to be? 2 over x minus 5 minus
1 over 2 times 2x to the third minus 3.
Times, and I'm just going to turn the top into 6x squared because we would have to take the derivative of that 2x to the third, silly chain rule. So do you have to use log properties? No.
But you're gonna.
But you'd be crazy not to, in my opinion. As long as you... Now, what if it's not a logarithm? Then... All right, let's do one more. Oof. So, for starters, are you guys okay with me rewriting this and doing the opposite of what we've been doing and write this as x squared minus 1 times x and combining them together? And then, because then when I look at those, I'm like, oh, I think it might be pretty easy to then just call this x cubed minus x, because those are a lot easier to take the derivative of. Then what? Now what we're going to do is the change of base formula, which we kind of talked about for a hot minute, but we didn't really talk about it that much. And it went like this. If I have, let's say, the log base 2 of 8, I could rewrite that as log 8 divided by log 2. Or I could rewrite that as the natural log of 8 over the natural log of 2. I can change the base to whatever I want. Okay, and so if I want to change this so that it's written in the form of the natural log, okay, because that's where I have my derivative laws, I can call this the natural log of x cubed minus x over the natural log of 3. Now, what do we know about the natural log of 3?
It's a constant.
it's a constant, right? So that might as well be a 2 or a 5 or whatever. It could be, it's just a constant number. So when I go to find the derivative, I'm really doing 1 over the natural log of 3 times, and that's just pulling that constant out to the front. Okay, then I'm doing, what is the derivative of the natural log of x cubed minus x? Well, I'm going to do 1 over x cubed minus x times, using that chain rule, 3x squared minus 1. How are we doing? Is this okay? And I would accept, probably maybe making this 3x squared minus 1 over the natural log of 3 times x squared minus x. Now, do you have to use log properties?
Should it be x cubed minus x?
That's what it says, is x cubed minus x.
Yeah, that's what it says.
You know what? Let's do these last two tomorrow. I feel like there's been a decent amount of overload today. What's going on Thursday? Quiz. What's probably the best way to prep for that quiz? Study. What's the best way to study for that?
Look over the material.
The blue packet. There's nothing on the quiz that isn't in the blue packet. Fair?